Okay, for the review, make sure you know that if you have two lines that are parallel, cut by a transversal, you know what the alternate interior angles are. These are alternate interior, that those are congruent. You know that the alternate exterior angles are congruent. So alternate exterior would be the green ones are alternate exterior, and the alternate interior ones would be, alternate exterior ones would be, here's another pair, and you know that the same side interior adds up to 180 and the same side exterior adds up to 180. Also know the converses. So the converses are, if you know the angles are congruent, then the lines are parallel. So state the postulate, theorem, or theorem that justifies each statement. Lines K and W are parallel. So if K and W are parallel, we have two sets of transversals. So why is angle 10 congruent to angle 12? Well, this is not even because of parallel lines. This is by the vertical angle theorem. So vertical angle theorem. Or if you want to write VAT, that's fine. Second one, why is angle 1 congruent to angle 5? So angle 1 and angle 5. Looking at just this transversal right here, angle 1 and angle 5 are corresponding angles. So by the corresponding angles postulate, CAP. Why does angle 2, why would the measure of angle 2 plus the measure of angle 7, so angle 2 and angle 7. You're still looking with this transversal, so angle 2 and angle 7 would be congruent because they're, or not congruent, but supplementary, because of same side exterior angles. They're on the exterior. And then why is angle 12 congruent to angle 15? So angle 12, angle 15, if this is my transversal, they're on the exterior and they're alternating. So by the alternate exterior angles theorem, and then why is 14 congruent to 11? So what's special about 14 and 11? Well, 14 and 11 are on the interior and they're alternating with this transversal. So if they're alternating and in the interior, then by the alternate interior angles theorem, they are congruent. And then the last one, why is the measure of angle 14 plus the measure of angle 10? So these two, why does it add up to 180? These are same side interior angles. So none of these are the converse because we're given that the lines are parallel. So if the lines are parallel, then we can conclude all of those angle pairs. This is the original one. The converse would be if I told you that angle 1 and angle 5 were congruent, then you can conclude that the lines are parallel. That's the converse. Okay, make sure we know how to fill in proofs. So we always write the given on the first line, and I need to mark it, A parallel to B. The angle 1 is congruent to angle 3 is always going to be on the last line. So let's look at why is angle 1 congruent to angle 2? Well, we know these lines are parallel, so what is special about lines or angles 1 and 2? What kind of angles are they if this is the transversal? They are alternate interior angles. So it's the alternate interior angle theorem says if the lines are parallel, then the angles are congruent. Why is 2 congruent to 3? What kind of angles are angle 2 and angle 3? They're vertical. So by the vertical angle theorem, those two angles are congruent. So now I'm down to the last line. So I need to look up the previous lines. If 1 is congruent to 2 and 2 is congruent to 1, so angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, I don't even need this middle part. I can conclude that angle 1 is congruent to angle 3. That is by the transitive property. So I fill in transitive. And then that's it. Okay, now we're going to find the angle measures and then provide justifications. So this symbol means that they're parallel. So I can, first of all, I know that angle 2 has to be, the measure of angle 2 has to be 100 degrees by vertical angle theorem. Always look for vertical angles. I think those are the easiest. Now if we know that these two angles are a special angle pair, if this is my transversal, then I know that the measure of angle 1 equals 100 degrees by the alternate interior angles theorem. Okay, number 11. But I want to make sure I don't put angle 1 equals 100 degrees because we're talking about the measure, so that's not the right notation. Okay, number 11. So I also know that these are parallel right here, and the green line is my transversal. So these two are special angle pairs. I know that the measure of angle 1 equals 75 degrees by alternate interior angles. And then I also have 1 and angle 2. So this means that the measure of angle 1 or angle 2 has to be 75 degrees as well by the vertical angle theorem. And then number 1 for number 12, parallel lines again. So first I'm going to look at 135 and 1, or you could do 135 and 2, but I know that the measure of angle 1 has to be 135 degrees by the corresponding angles postulate. They're both in the upper left-hand side, so by the corresponding angles postulate. And I know that the measure of angle 2 equals 135 because it's vertical with these two, or by alternate exterior angles. This is alternate exterior with this. So I could write the alternate exterior angle theorem, or I could write that it's vertical with angle 1. And then down here, state the theorem or postulate that justifies each statement. If the angles are congruent, then the lines are parallel. So with respect to P and Q, angle 1 and angle 4 are corresponding angles. But because it's giving me if the angles are congruent, then the lines are parallel, this is the converse of the corresponding angles postulate. Okay, number 2. Why is angle 6 and angle 8 congruent? Because these two lines are parallel. So if I know the lines are parallel and the angles are congruent, then the angles are congruent. That is by the alternate interior angle theorem. And then 3, why is 7 plus 8 equal 180? Those are same side interior angles. Why is angle 5 congruent to angle 8? That's by the corresponding angles postulate. And the number 5, if the angles are congruent, then the lines are parallel. 2 and 4 are alternate interior angles. These are the two parallel lines. This is a transversal. So 2 and 4 are alternate interior angles. So because it's if the angles are congruent, then the lines are parallel. it's the converse of the alternate interior angle theorem. Why is 8 congruent to 9? That's the vertical angle theorem. 7, if angle 3 is congruent to angle 8, so angle 3 and angle 8 are corresponding angles with this, my transversal. So if the angles are congruent, then the lines are parallel is the converse of the corresponding angles postulate. And then 6 is congruent to 9 by just the corresponding angles postulate because I already know these two lines are parallel. And then number 9, if the measures add up to 180 of 2 and 6, then the lines are parallel. So these are same side interior angles. Same side interior angles, but it's the converse because we know the angles add up to 180, so then the lines are parallel. Okay, a couple more proofs. So we're using the same diagram for each. So given that L is parallel to N, I have those already marked right here. Why is angle 2 congruent to angle 6? What kind of angles are angle 2 and angle 6? They are corresponding angles. So by the corresponding angles postulate, the angles are congruent because the lines are parallel. What is special about angle 4 and 2? What kind of angles are those? By the vertical angle theorem, those two angles are congruent. Now I'm bumping up to 6 and 4. So well, we already know that 6 and 4 are congruent because they're alternate interior. But if you look at this proof, I have angle 2 is congruent to angle 6 and angle 4 is congruent to angle 2. So I'll write it out like this. Angle 6 is congruent to angle 2 and angle 2 is congruent to angle 4. We can bypass this middle part and say angle 6 congruent to angle 4 by transitive. And then the last proof I just realized we just did because I'm given this information and I'm giving this is the same as this. So that's it. This was the last proof. So this is a review. Make sure you know all those different theorems and how to use them.